All right, so this is a problem related to work, and it's parallel to the questions given in Science 8 Matatag uh, curriculum exemplar. Okay, uh, a 30 a 30 Newton force was applied to a 5 kilogram wooden block placed on a cemented floor having a frictional force of 10 newtons. The force caused the wooden block to move at 5 meters to the right. Okay, that's the direction of the object. If the object moves to the right, that's the displacement of the object moving to the right. And we have an applied force that is 30 Newton, same direction. Okay, because if you have force, displacement will be following that direction of the force. That's a positive work, so our answer must be positive. This is the applied force, and this is going to be the displacement of the wooden block. Okay, so let's try to figure out the the work done by the applied force to the wooden block. Okay, so let's gonna do it now. Okay, we will be expecting to have a positive answer because our applied force and the displacement of the wooden object, their directions are the same, going to the right. Okay, so let's have our given first. Given we have an applied force of 30 Newton, and we have a 5 kilogram mass of the object, but I guess it's it's not needed in our calculation because in doing work, it's independent with the mass of the object because we just need force and displacement. So we will just mark it here at x. Mark it as x. Okay, and we have a displacement in the right direction. So we have positive 5 meters, meaning to the right. And then we have the friction force, which is 10 newtons. Remember, friction, it's always opposing the applied force, opposing the applied force direction. Okay, so let's have the work done by the applied force. Okay, our formula will be force times displacement, and this time we will gonna have the cosine theta here. I will show to you uh, how to use this variable here. If you have your scientific calculator, you can get the value of your cosine theta. Okay, let's review. The direction of the force applied is going to the right, and the direction of our displacement in the problem, it's going to the right. That's a displacement. Same direction, so that's a positive work. If you notice, if these two vectors are in the same direction, our angle will be 0 degree. No angle form because the displacement and the applied force directions are same, are in the same direction. So our theta or our angle is gonna be 0. Okay, so let's continue. Work done by the applied force equal to FD cosine theta. Then you have the force 30 Newton, and we have displacement, it's positive 5, and then we have cosine theta. All right, so this is going to be 150 Newton meter. And what's cosine theta? If you will put it in your calculator, there's a button here, COS, that's cosine. Press that one and then input the angle. The angle this time is 0. And if you will input cosine 0 in your calculator, the answer will be 1. So we can replace cosine theta with 1. Okay, so our answer is still 150 Newton meter, and it's a positive work. It makes sense. Okay, so we're done with that. Work done by the applied force. This time we will have work done by friction. Same formula, force displacement, we'll have the cosine theta now. Let's try to compare the directions or the vectors of our force here, which is friction, and the displacement of our wooden block. It's still to the right, okay? So let's say this is going to be the displacement of our block, and friction oppose the applied force. So if ever the applied force is going to the right, that's the applied force, meaning the friction is moving opposite to that, slowing down the object. So our friction will be in that direction. F is for friction. If you notice, we have an angle form that's 180 degrees. If you will have to input cosine theta, and our angle this time is 180, so cosine 180 degrees, what is the answer? Press the cosine button and then input 180. The answer will be 1. Okay, so cosine 180, it's equivalent to negative 1. Because we have 180 degree formed, the displacement due to the applied force, which is going to this direction, and our friction is in that direction. So in that case, we form a 180 degrees. Put that one in your calculator, cosine 180 degrees, and it will give you negative 1. The force done by friction, it's 10 Newton multiplied by displacement of 5 meters. The answer will be 50 Newton meter times negative 1, that's negative 50 Newton meter or joule. So the answer is negative. It makes sense. It's a negative work because the direction of the force is opposite to the direction of displacement. So it's a negative work, right? So we're done with friction force. Now we will be calculating the remaining forces. I will just delete first or erase first the content here. Okay, this time we will be calculating the work done by the normal force. I will write again the given. We have the applied force of 30 Newton. We have the work done by the applied force. That's 150 Newton positive, same direction of the force and the displacement of the block. We have the friction calculated earlier, and that's gonna be 50 Newton. And don't forget, it's a negative work because the friction is going to that direction and our displacement of the object is going to the right. Okay, different direction, so the answer will be negative work. Okay, now the all right, this is the work done by friction, and the value of our friction, my apology, it's just 10 Newton. Okay, 10 Newton. Now, let's have the normal force. Remember, when we are talking about forces, if we have a box on the ground, this will be influenced by a downward force of gravity. And of course, we have a force that is always perpendicular to the ground. So when we say perpendicular to the ground, we have an upward force. And that's what we call the normal force. Perpendicular, meaning to say it will form a 90 degrees here. Okay, I will try to uh, do it again. This is the ground, and we have a normal force going up, and then we can form a 90 degrees here. That's 90 degrees. And let's try to find out what's the work done by the normal force. Formula, FD cosine theta. We will be utilizing the cosine theta now because it's needed. We have the force. If you look at it, we have the mass. This time we can use the variable of mass. The mass of this block is 5 kilogram. And remember, this gravity here, that's the the weight of the block, and it's equivalent to force. Remember, the formula of weight, it's just mass times gravity, and that's going to be the force. So the mass in this particular illustration, it's 5 kilograms times 9.8 meter per second squared gravity on Earth. And if we will input it to our calculator, we'll have 49 uh, kilogram a meter per second squared, or also known as Newton. So our force here, it's gonna be 49 Newton times the displacement of our moving object. Okay, the displacement is still uh, going to the right, and we have a normal force that is going there, forming 90 degrees. And as you can see, the directions are not the same, right? Not the same. And yeah, 90 degrees, or it's perpendicular to one another. So for sure, there's gonna be zero work. No work is done in this scenario, but let's prove. Okay, 49 Newton times the displacement, that's 5 meters. And we're forming 90 degrees. If you will input cosine theta or cosine 90 degrees in your calculator, the answer will be cosine 90. It's gonna be uh, 0. Gonna be 0. It is equivalent to 0. So this cosine theta here is 0. So our answer will definitely 0 joule. No work done because the direction is not the same. Okay, I hope it makes sense. Next, we have this next force. I will just have to our normal force, or the work done by normal force, it's equivalent to 0 joule. Work done, my apology, this is Newton meter. Work done, this is gonna be Newton meter, okay, or joule. So in normal force, no work. What about gravity? It is the displacement of the block going to the right according to the problem. And in our gravity, it's going down for sure, right? That's the force of gravity. We are now forming 90 degrees, so therefore, the answer for this will be 0. Okay? And the work done by gravity is same here. The normal force, earlier, it's 49 newtons. That's the force. And um, if you could still recall, these two vectors here, we have the normal and gravity. They are balanced forces. So if we have 49 Newton as our normal force, our gravitational force also will gonna be, or the weight is equivalent to force. If our force, normal force, is 49, the weight will also be 49. Then we have cosine theta. It forms 90 degrees. So cosine 90 degrees, it's just equivalent to 0. So again, work done by gravity, it's 0 joules. Okay, we're done with gravity. Now let's have the net force. Okay, we have the last part that we need to know, the work done by the net force. Okay, let's try to have two solutions here and let's compare. Okay, let's try to focus now on the applied force and the friction force. Okay, to get the net force, not the work, sorry, to get the net force, We have applied force going to the right. Okay, that's the applied force. So we can have positive 30 Newton. And we have our friction force. It's opposing to the applied force. Okay, it's opposing to the applied force. That's going to be our friction force. It's going to the left, so we can have minus 10 Newton. 30 minus 10, it's 20. 20 Newton. It's positive. Therefore, the object is still going to the right. Okay, that's a displacement, and the force is still, the applied force is still going to the right with little newtons of force. Okay, but still, again, our answer is positive. Therefore, we have positive work in this case because our net force is positive. So it's going to be uh, positive 20 newtons. So work done by our net forces, we have FD cosine theta, and the value of our net force, we just calculated it. It's 20, positive 20 Newton, and we have a displacement of 5 meters. Cosine, what's the value of our cosine this time? Let's try to find out. So 20 newtons times 5 meters, that's going to be 100 Newton meter. And cosine, what's the value of our theta? Let's try to illustrate. This is the displacement of the ball. The block is going to the right. Okay, that's the displacement. And our net force, as you can see, it's positive. So it's, you know, uh, it follows this direction. Okay, it's a positive work. So it's gonna be 0 degrees, no angle form. So we have 0 degrees here. Cosine z cosine 0 degrees is equivalent to 1. So 100 Newton meter times 1, it's 100 uh, Newton meter or joule. This is the work done by a net force. It's a positive work. Okay, it is lesser than the applied force alone because some of the work is being transferred to the friction force because of the presence of friction force. So some of the work there is being transferred to the work done by friction. So that's 100 joules. So try to have the other solution. We have to know we have, let's focus on the work here. 150, that's the applied force plus the friction force. If you look at the applied force, the direction of the applied force is to the right, so that's positive. That's going to be positive 150 joules. And our friction force, it's always opposing. It's going to be negative. So we can have minus 10, not 10, but the work done by friction force, it's 50. 50 joules. The answer, 150 minus 50, the answer is going to be positive 100 joules. Same with our solution here. So that's it. I hope you enjoy and you learn something from this video. And if you like, you can click the like and you can comment something, or you can subscribe so that I can have the motivation to do videos like this. Thank you and see you in my next video.